let's take a simple example where there is a car which is accelerating in this direction, and there was a pendulum which was hanging earlier vertically, but as it accelerates, it deflects from its vertical position and it makes an angle theta with the vertical. We have to find what is this angle theta. We shall find the solution using an inertial reference frame and then non-inertial reference frame, and then we see that is whether our answer matches or not. Let's first take inertial reference frame, that is non-accelerated reference frame. It means the person is on the ground. He is not accelerating. So what he observes is that is onto this block. He sees what are the forces which are being applied on this block. One is, if we draw the free body diagram, we know that his tension is here and mg is going to be in this direction. So there are going to be two forces acting on this block, on this bob pendulum, that is one is T, the other is mg. This person observes that is when the car is going in this direction, so this pendulum, this bob is also moving in this direction along the x-axis along with the car A, but it is now not moving along the y-axis. Once the car is moving with the acceleration A, the pendulum will be moving with the same theta throughout its journey. That is, this mass will not be either going up nor moving down, and along the x-axis this will have the same acceleration as that of the car. So this person observes that this mass is not moving. If we take two axes, one is x-axis, this is y-axis. So this person observes that is acceleration of this is along the y-axis is equal to 0, and acceleration of this acceleration along x-axis is equal to a. That is the same as that of the car. We have to find what is the value of theta. So what we do is, what this person does is, that is he breaks t into two components. One is t cos theta, the other is t sin theta. This angle is theta. We make x and y axis over here. This and this, they are verticals. This is a line which cuts it, these two parallels, alternate opposite angles. If this is theta, so this is also theta. So then we break this t into two components. This becomes the cos component, this becomes the sin component. So this becomes t cos theta and this becomes t sin theta. Our observer is this observer. He sees that is this block is neither going up nor coming down. He sees that this block, this mass is neither going up nor going down, that is acceleration along y-axis is equal to 0. When acceleration along y-axis is equal to 0, so he says that is upward forces, they have to become downward forces. Upward forces, they have to become downward forces. So t cos theta is equal to mg. Why? Because the net force along y-axis is equal to 0. Because acceleration on y-axis is equal to 0, F is equal to ma, so that's why the net force along y-axis is equal to 0. What he observes along the x-axis, that is this block, this mass is going this way with the same acceleration as that of the car. If this is going this way with the same acceleration that of the car, then obviously there has to be a force. What is the force along the x-axis which is responsible for its acceleration? That is t sin theta. So along x-axis, if we talk about the x-axis, he observes the acceleration that is equal to a, ax is equal to a. So he writes the equation that is t sin theta for x-axis. This is the force, resultant force, this is net force along x-axis that is responsible for acceleration along the x-axis. T sin theta is equal to mass into acceleration on the x-axis is the same as that of the car. Now if we take this as equation 1, this is equation 2, if we divide the two, so this comes out to be t sin theta by t cos theta is equal to ma by mg. So this comes out to be tan theta is equal to a by g, or theta is equal to tan inverse a by g. So this is the angle with the vertical this string will be making. Now what if our observer is an accelerating reference frame? He is accelerating. So if the observer is accelerating, let's put him over here. So now this is the observer, he is going to write the equations. So our observer is over here, so this is an accelerating observer. So this is an accelerating reference frame or accelerating observer. So now if he wants to write all the equations, so it means in addition to all the real forces, that is two forces, T and mg. T is there, you can't disturb the real forces. T is over here, mg is over here. He cannot disturb these two forces, but in addition to these two forces, because he is accelerating, because he wants to apply laws of motion, so in addition to these forces, he will add one more force, which is a pseudo force. He is accelerating with the car in this direction. He is observing this block, so he will apply a pseudo force in this direction. The direction of pseudo force, fictitious force, imaginary force, is the direction opposite to the direction of acceleration of the observer. He is accelerating this way, so pseudo force will be in this direction. And what will be its magnitude? Its magnitude is going to be mass of this into acceleration of this. He is going this way with the acceleration A, so this is ma. He is going to apply a force ma in this direction, which is a pseudo force. Now, how our diagram changes is, rest all remain same, that is components, the components, they can be broken the same manner, but this is one more force he adds in this direction, that is m into a. Now he says, I'm competent to apply laws of motion. If he is competent to apply laws of motion, so whatsoever observes, he will write it down. So now this person writes down, that is this block, this mass is neither moving along the x-axis, that is summation of forces along x-axis is equal to 0, because he is also now in the car. This mass is stationary with respect to him. This is not accelerating, this is neither accelerating along the y-axis nor accelerating along the x-axis. It means for him net force along the x-axis should be equal to 0 onto this block, and similarly net force onto this should be also be 0 along the y-axis. So summation of forces along x-axis is equal to 0, and summation of forces along y-axis is also equal to 0. So along the y-axis, he says that is t cos theta is equal to mg, t cos theta is equal to mg, and along the x-axis, he says that this is stationary. So this side force is equal to this side force. So t sin theta is equal to ma. So t sin theta is equal to ma. If you look at the equations, t sin theta is equal to ma, t sin theta is equal to ma, t cos theta is equal to mg, t cos theta is equal to mg. So once you divide these two, you get the same answer. So whether you use the accelerating reference frame method or inertial reference frame method, the answer will come out to be the same. By using the concept of accelerating reference frame, pseudo forces, fictitious forces, at times the questions, they become much easier to solve.